Hi, I'm Daniel with PVComplete. PVComplete is an end-to-end solar design software platform that is made up of two applications, PVSketch and PVCAD. PVSketch is an easy-to-use solar sales proposal design software that runs in a browser on any type of device. PVCAD is basically a solar-specific type of AutoCAD software that only runs on Windows desktop computers. PVCAD is intended to be used for engineering design and plan set creation. The nice thing about PVCAD is you don't need an AutoCAD license if you have PVCAD. Most of the AutoCAD functionality is already included. The nice thing about PVSketch is that it's free if you only are doing up to 5 solar projects per month. Of course, if you're taking a heat shrink class, we'll give you a free academic license for both softwares, and I'll talk more about that at the end of this video. PVSketch and PVCAD have been designed to work together, so you can take your PV project all the way from sales proposal to the final construction plan set in one plan form, and hence our company name, PVComplete. So let's get started. I'll show you the workflow, how to get started building a project in PVSketch. So first thing that happens when you log in is you want to enter the address of your project and find the building you want to design on the map, trace the roof using our line tool. Then, using either the circle tool or the line tool, we want to go in and identify any obstructions on the roof, like air conditioning units or vents that are going to obstruct the location of our solar array. You'll notice there's a little sidebar on the left of the screen, on the left of the map, and every time we create a new object in PVSketch, it gets added to that list on the left-hand side. So now I'm going to go to the left and pick the project tab, and here I'm just going to enter information about the project, like the customer name and the project name and number. And then you'll see here this list of objects on the left. Every object has properties, a height and a setback in the case of obstructions, and height, setback, slope, azimuth in the case of the roof object. Now I'm going to go over to my System tab, where I can pick from our library of solar modules, mounting systems, and solar inverters in order to pick the equipment that I want to use for this particular solar project. And once all that's done, I'm going to go here and hit the big blue button, and the software will generate a layout for this particular project. And once I've done that, I can export a sales report. The intent here is this would be a document I can present to my customer that I'm trying to show them what their solar project might look like. You'll see the sales report can be customized with your own logo, and then we'll show the customer how much energy their solar project will produce in a year, what their project will look like, how many trees they save, and what equipment you specified in terms of mounting, racking, and inverters and modules. When I've done that, I can also export this drawing to PVCAD, and this is where we see the power of the platform. I create this link which goes onto my clipboard. I can send it to anybody that has PVCAD, and if they launch our PVCAD software, they can import that clipboard link and instantly generate the same project inside of the PVCAD environment. So this is PVCAD. It has all the same functions that you're used to if you've ever used AutoCAD before, but it also has this PVCAD ribbon that we've added on top of it. And the one button we have here is the Import from PVSketch ribbon, where I usually start my project. So I'm going to click Import, and the wheels will spin, and you will see that everything that was drawn in the PVSketch software gets automatically redrawn here for us in AutoCAD. The other thing that's nice is the imagery comes in with it, so you can see that your drawing is properly scaled to that imagery. And then if you use one of the templates that we provide, we have these intelligent title blocks with drawing properties set up so that all the information from PVSketch populates in the title blocks. So you get the customer's name and their address and the module that you choose, and equipment, and so on automatically in the title block as well. Just want to show you also that you don't need to use PVSketch to import your initial drawing. You can directly go to PVCAD if you're comfortable in the AutoCAD environment. And you see here, you just draw any shape in AutoCAD, like a rectangle, and then you go to the PVCAD window and you give it properties such as setback and height and such. And then you could define, and now it knows it's a roof. And similarly, if you want to put any circle or any polyline on top of that roof object, you can then go and define them in the PVCAD window as being obstructions. If you give the obstructions properties of height and setback, you'll see the drawing will automatically put in shade keepouts and setback keepouts for those objects. And what's nice is once you've defined an object, if you need to change the object height, because maybe you do an audit of the roof and you see the height has changed, you can simply click on the object and then modify its height and its setback properties, and it'll automatically update the drawing for you appropriately. So going back to our drawing that we imported from PVSketch, one thing that's nice about it is all the information comes in imported on proper AutoCAD layers. So if I want to, for example, turn off a layer like the image layer, I can turn it off. You can see also the roof outline is on its own layer, and the obstructions are on a layer, the setbacks are on a layer, and the layout of the module is on its own layer in AutoCAD. The next thing I'm going to show you is a cool feature that we call versioning. Versioning is useful for doing value engineering and for comparing different design options within the same PV design. So if you go to your PVCAD ribbon, you'll see here on the top there's a little drop down and it says version. The first version says panel claw. And now I'm going to create a new version. I'm going to say, okay, version 2 is going to be Unirac version. Now what you're going to notice as soon as I create a new version is that the underlying roof definition and the location of all the obstructions and shaded areas and setbacks remain intact, and all that gets stripped off the design is the module layout itself. And then what I'm going to be able to do is I'm going to be able to go to my PVComplete window, my PVCAD window, and pick a new mounting system, a new module that I want to use for that mounting system, and then I can redo a second layout, and then the software will make it easy for me to compare the two layouts with each other side by side. So what I'm showing here is I'm going to pick Unirac RM5, and then I'm going to go and I'm going to pick make layout, and the next thing it's going to ask you is for the azimuth. So in this case it's pretty obvious you'd want to go north-south with your array layout here, but on some buildings they're not aligned north-south. You might choose to align your array with the building rather than going north-south. So it's just going to ask you the azimuth. If you want due south, just hit enter. It's going to ask me where I want to place the first module in my kind of grid of modules. This can be fun too because it's amazing because if you pick a different starting point for your grid, you can get different results in terms of more or less modules will fit on that roof. You can use the Shift Tab keys to kind of shift the module insertion point around, so you can pick different corners of the building that you want to start your array layout at. And then, skipping ahead to the Summary tab, we can compare the two versions side by side, so we can see how many kilowatts, how many solar panels fit on the roof, and then if you actually calculate the energy here, it'll do a quick energy calculation and tell you how many kilowatt hours each system will produce. Another cool thing about the Summary tab is that as you make changes to your layout, it'll update in real time. So if I go in here and I delete modules from my roof, you can see that my my power and number of modules is updating automatically in real time. And you also can add modules back onto the roof in a very efficient manner. So if you go here, Add Panel, you pick a starting point for the panel you want to start with. You can just drag out like this extra panels you want to add, and it adds them back into the model. So moving on to the next tab, which is the Electrical tab, we'll look at some of the electrical balance of systems for this project. So because I imported this from PVSketch, the inverter has already been chosen for me. We have the SMA tri-power. And the first thing it's going to tell you is here's all the valid string lengths for this inverter based on the temperature information that we provided in this first project tab. And actually, if you right click here on the temperature button, it'll open the ASHRAE map where you can look for standard high and low temperature values for your region. And then it'll tell you right away, so I have strings of 22, so I have 9 strings of 22 in my drawing. I can add 18 modules or remove 4 modules to get to an even number of strings. So again, in real time, if I delete 4 modules, I have now exactly 9 strings. Now the tri-power in this case can actually take different length strings in one inverter, and I can show you how to do that as well, but it's a little tricky, so I'm not going to cover it in this video, but feel free to contact us at pvcomplete.com and I can walk you through how to do that. So the next thing I'm going to do is I'm just going to insert a physical location for this inverter into my array, and here's inverter number 1. And so then I'm going to go ahead and I'm going to insert another inverter. It'll automatically call inverter number 2. And here's inverter number 3. And then we're going to attach 3 strings to each of these inverters in my drawing. So the way I like to string, there's a couple different ways. String auto is not as auto as you might think. It just goes either north-south, east-west, south-north, kind of goes in a single direction. String manual strings in the order you select modules. So if I pick this as my first module in a string, I pick it first, this will be the second module in my string, etc. If you use the fence command in AutoCAD, you can actually just type F for fence. It makes it really easy to select modules just by drawing a line through the modules in this order. And so you can see that, I'll show you when this is done. It's a really convenient way to make string maps for your projects. So it'll follow the order that I selected the modules. See that? And it'll string them all. If you're in a hurry, you can also just go string manual and just grab your whole drawing, and AutoCAD will decide how to string it, but sometimes it makes poor decisions like this. So what you can do then is you can remove that string and go back to string manual and try and string it in a more logical fashion, just for the string that you missed. Let's see if I can figure this out. Maybe not the best string map ever, but you get the idea. And then what I'm going to do now is I'm going to physically pick strings in my string map and connect them physically to this inverter. And this is important because it's going to allow me to extract a bill of materials from this drawing with actual wire lengths for all the wire and conduit I need for my drawing, which requires a physical representation. So I'm going to hit source circuit conductor. A source circuit, you remember, is defined as the conductor that goes between a string and an inverter or a combiner box. So I pick 3 source circuits. When I'm done, I hit enter. I'm going to pick something called an alignment point. I want all the wires to go through my alignment point and then into my inverter. And you'll see the system puts in wires from the beginning and end of each string into my inverter. And you notice also every string is uniquely identified now with a number. So string 1, string 2, string 3, etc. So I'm going to do it again. Source circuit conductors. I'm going to grab 3 more strings. This one, that one's already been taken, so that one, and this one. And we'll go into my alignment point and then to inverter number 2. And then finally, I'm going to grab the remaining strings and those will go into inverter number 1. So it's a little messy. You can always clean it up. You can move these strings around by hand if you need to. You can actually insert vertexes into a string if you want to add your own wiring, routing, and such. I won't go into too much detail there. And then when you're done, what I'm going to do next is I'm going to add an AC panel. You can use a combiner box, but most people don't use combiner boxes anymore, so I won't bother showing that. But here's the AC panel 1. And then I'll go AC circuit conductor, and I'll just click the inverter and connect it to the AC panel. And now it knows that this is a 40 amp panel with a 40 amp breaker. And then if I add another one here, it is now a 60 amp panel with 2 40 amp breakers. And then I'll do one more here, and now it's a 120 amp panel with 3 40 amp breakers. And this is a minimum. Obviously, standard panel sizes don't come in 120 amps. This would actually probably be a 200 amp panel with 3 40 amp breakers. So once I've defined that, I can save my drawing, and then I can export a bill of materials for this project. So I'm going to export bill of materials. And what it does is it exports it to an Excel file that goes into whatever folder my drawing is in with the /BOM. So here's my bill of materials for this project. It has the project name and address and everything up here. This first section bins modules according to the location in the array, whether they're interior zone modules or corner zone modules. Here's the total number of modules on my layout. This is really more applicable if we weren't using a mounting system that's already supported. In this case, because we're using Unirack mounting systems, I'll show you how to get an actual Unirack BOM out of this. But the other thing we get here is the total. So this is in whatever units my drawing is in. My drawing is in units of inches right now. It could be feet or meters or whatever, but it's in units of inches. So this is how many inches of number 10 copper you need for this project. Number 8, number 10. Inches of EMT conduit, 3 inverters, 1 AC breaker, These are jumpers which are, anytime a string goes from a module that's not directly adjacent to it, it adds a jumper to the BOM. And then here's actually every single wire in my drawing. So here's wire number 1, which goes from string number 1 to inverter number 3. It's 10 gauge, and that's how long it is. And this is wire number 2, string number 1, inverter number 3, it's 10 gauge. And this would be useful if you wanted to try and prepare some of your wiring at the shop before sending to the roof. It tells you how long each individual conductor run is in your drawing. So here's the conduit, or this, what we call conduit run. It's actually a number 8 gauge AC wiring, conduit run number 1. There's the neutral ground. And then here's the actual conduits for each conduit run and how long they are and the size of them. I'll show you now how to pull up the Unirac BOM. For certain manufacturers, we have integrations where you can get bills of materials and ballast plans. Unirac is one of them. So if I put in here PVCGet Unirac, it's going to ask me to fill in some information about my project that I haven't filled it in yet. The critical pieces are my wind speed and snow load, my risk category. This is not so important. It just kind of does a validation on whether your roof can support the weight that you're putting in there. Add your email address. And then when you're done, you can submit this, and what this will do is it'll actually do a wind zone exposure calculation to produce an accurate bill of materials and a ballast plan for this particular building. And again, it puts us in this subfolder, this BOM subfolder. So what I get out of it here is this cert letter from Unirac. I also get the ballast diagram that shows how many ballast pavers need to go in each tray for this particular design. So not every manufacturer do we have an integration like that. We're trying to add more all the time to our list of supported manufacturers. But right now, and sometimes we'll have like bill of materials. So for example, Polar, right now we have bill of materials but not the ballast plan. SunPower, we only have the layout, we actually don't have any bill of materials at all. Iron Ridge, we have the full wind calculations, and Unirac, we have the full wind calculations. And so we're always working to try and add more mounting systems to our software. And then you'll see now my new bill of materials, because I've run that, now has the full Unirac bill of materials along with the right part numbers. The next thing I'm going to show you is how to generate a single line diagram for this project. So I'm going to save the project again. So what I'm going to do next is I'm going to click this single line diagram button. And here's my single line. And so what you'll see here is 3 strings of 22 series connected modules. There's my wire size. 3 modules. Here's my 3 inverters, 1, 2, 3, into an AC panel with 40 amp breakers, combines them together. Switch meter, line side tap. Now, what happened here, first of all, I kind of skipped ahead, but we do have a settings tab here where you can specify some preferences for your system, copper versus aluminum wire, the height of the conduit above the roof, the kind of conduit type you prefer to use. And these version settings, as well as what I physically drew in my drawing, get exported into an Excel file, which contains all my calculations for my electrical wire sizing and such. I'll show you that in a second. And then what happens is the drawing will read the results of those Excel calculations and paste all the relevant information back into my blocks. So each of these single line elements are themselves a block. So there's my inverter block, my modules block, my AC panel block. What's nice about our single line drawings is that the blocks are actually often contain multiple visibility states that allow you to modify them. So as an example, this is a generation meter, which often is not required. So if I click on this block, you'll see that there's a little arrow here, and it says I have the option of no meter, just a meter without the switch, unfused switch, or fused switch. So I can change how my single line looks by adjusting that state. And some of these blocks that are just conductors actually have hidden elements. So this one actually has a hidden, either an unfused disconnect switch or a fused disconnect switch hidden right within that block. Similarly, this is my intertie panel. This is a line side tap. If I want to go load side, I could go load side, and now my panel will have a load side interconnection breaker. There's a lot of cool things if you poke around here hidden inside these blocks that you can play with. Now, if I go back to that same folder, that BOM folder where I initially found my ballast plan and such, I can pull out the Excel sheet that was used to calculate this single line. So let's go do that. And what you'll see here, if we go all the way to the left, these are all the import tabs. This is information from the drawing that was imported into this Excel sheet. So you can see that the first import tab is all those version settings that I talked about a second ago. So these version settings got thrown into this import version settings tab. Here's where all the information about the solar modules got imported in. Here's where the information about the inverters that I chose from our inverter database got imported in. Here's the AC panel information that got imported into my spreadsheet. So all this stuff got sucked out of the CAD drawing automatically, placed in this Excel spreadsheet, and then from there we do some math. So first of all, we have this nice parameters tab that you can use to override things. So if you decided that you actually didn't want to use copper, you want to use aluminum, rather than going back to the drawing, you could just change it here in this parameters tab and it'll change the calculations in my next tab. This is my calculations tab where I'm actually going to do all the math, calculate things like wire size, conduit fill, and voltage drop. And then once those calculations are done, the next tab is called my sheet set tab. This is where we try and present the results of those calculations kind of in an organized fashion. So you'll see here, here's my system properties, my temperatures that I used, my module properties, here's my DC string characteristics, here's my AC characteristics. And what I like to do now is take these things and basically paste them back into my CAD drawing. So I'll take like this temperature systems box, just copy that, go back into AutoCAD, create another like section where I want to have my tables, and paste this back into my AutoCAD drawing. And then I'll go back and do the same thing. I'll grab the module properties, add those in. I'll grab my inverter information, put that into my drawing. DC string characteristics, and my inverter outputs and combined output of all my inverters together. And then last but not least, voltage drop calculations are up here in the corner. And so once I've done all that, the only last step that remains is to assemble my drawings. So often, this first tab, I'll be for my array layout. What I often do now is I'll just go in here and I just hide the layers that are not really relevant as a presentation layer. So I'll just kind of get rid of a lot of the electrical balance of system layers that I don't think they really need to see, just so that my array layout looks a little cleaner. And then I'll go here and here's my single line diagram. And here you'll see that we have some instructions here for how to import from the Excel. I'll just delete those instructions. I've actually already imported them, and then where are my tables? Here they are. Here's my electrical calculation tables. Voila! There's my, at least my first 3 sheets towards getting my permit plan set ready for submit. That pretty much concludes what I'm going to show you today in this video. Obviously there's a lot of capabilities that I didn't have time to cover in today's demo. We have a whole utility scale mode, for example, that we could talk about that I haven't had a chance to cover. But just go to our website, PVComplete.com. We're always happy to provide customer support and training. And I'll remind you also that we're going to offer everyone who's taking the HeatSpring class free use of our software while they're taking the class. And so again, go to our website. You can download a free trial of PVCAD. You can subscribe to a free account on PVSketch, and then if you need more projects in PVSketch, then you can get it for free. Or if you need more than 30 days on PVCAD, that you can get as a free trial, just send us an email. My email is daniel.sherwood@pvcomplete.com, and we'll be happy to extend more projects and more time on your trial so that you can use the software while you're taking the HeatSpring class and learning about how to design megawatt solar projects. Thank you.